Hello everyone. Today we are going to discuss about powder metallurgy technique. So, powder metallurgy technique, it is a manufacturing process of producing commercial product from metal and alloy powders. Before we go through the details of powder metallurgy technique, let us know why powder metallurgy technique is followed. Powder metallurgy. So there are a number of reasons to adopt powder metallurgy technique. Okay. So first one is the its cost effectiveness. Second one, number of properties. Powder metallurgy component can achieve number of properties like mechanical properties, physical properties, chemical properties. Okay, so next is the different complex shapes and unique shapes can manufactured through this powder metallurgy technique. Okay, so the next point is the metal which are very difficult, the metals which are very difficult to form, to cast due to high melting temperature. These metals are also manufactured by this powder metallurgy technique. Okay, so there are a number of reasons to adopt this powder metallurgy technique. Okay, so powder metallurgy technique is basically used for to get some desirable properties, some desirable mechanical physical properties like controlled porosity, mechanical strength, density and ductility, etc. Okay, so powder metallurgy is the manufacturing process in which commercial products are manufactured by metal or alloy powders. Okay, so in powder metallurgy technique, metal or alloy powders are properly mixed. Metal and alloy powders are properly mixed. Then the mixed metal powders are compacted or compressed in a steel die of desired shape of the parts to be produced. Okay, then the compacted metal powders are heated below the melting temperature of the base metal, below the melting temperature of the base metal. As a result, the metal powders are bound together by interparticle bonding to form a new product. Okay, so this is the basic principle of powder metallurgy technique. Okay, so this is a powder metallurgy technique. Then it is a basic principle. It is the manufacturing process in which fine powdered materials are blended, pressed into a desired shape, that is known as compacted, and then heated, it is known as sintered, in a controlled atmosphere to bond the contacting surfaces of the particles and establish desired properties. There is an important information. Uh, in the sintering process, when the metal powders, when the compacted metal powders are bind together to produce a new component, new product by interparticle bonding, the temperature of this sintering process is kept always below the melting temperature of the base metal. Okay, this is the basic principle of powder metallurgy technique. Okay, so the next slide is the what are the steps involved in powder metallurgy technique. There are four basic steps involved in powder metallurgy techniques. Okay, so first one is the production of metal powders. First one is the production of metal powder. In this step, the metal and alloys are converted into powder form. Next step is the blending or mixing. In this step, the metal powders are properly blended or mixed. Okay, so next step is the compacting or briquetting. This is the step of green compact. Okay, so here the blended powders are compacted. Okay, then the next step or last step is the sintering. Okay, so let us discuss the first step, production of metal powder. Okay, so production of metal powder, it is the first step. In this step, metal and alloys are converted into powder form. Okay, so there are different methods adapted for production of metal powder, like physical, chemical and mechanical. Different methods are followed for production of metal powder. Okay, according to the shape and size of the metal particle. Okay, so it is the first step where the metals or alloys are gets powder form. The powdered metals are produced mechanical, physical and chemical means depending upon the particular application involved. Okay, as I said. So what are the methods of producing metal powders? First one is the crushing, second one is the machining, third one is the reduction, fourth one is the condensation of vapor metal, fifth one is the atomizing. There are a number of steps, or there are a number of methods. Okay, so methods used for producing metal powders. Okay, so first one is the crushing, second the machining, third is the reduction, fourth is the condensation of vapor metal, fifth is the atomizing. Okay, so crushing, this method is basically used for brittle material. This method is basically used for brittle metal. Okay, in this method the metals are crushed in a crusher like rapidly moving hammer, jaw crusher, etc. Okay, in the crusher the metals are crushed. So this method is basically used for brittle material. And the second method, machining, in this method the chips of the chips are produced from metal by scratching, filing. Okay, particularly this method is used to produce chips by scratching, cutting and filing. Then the chips are subsequently pulverized by crushing or milling. Okay, then next method is reduction. So in this method the compound of metal is reduced. In this method the compound of metal like oxides are reduced in the presence of carbon monoxide or hydrogen at a temperature below the melting temperature of the metal in a controlled atmospheric furnace. Okay, so this is the process of method of reduction. Then condensation of vapor metal. In this method is particularly used in case of zinc, cadmium and magnesium. Okay, so for example zinc zinc oxide is heated with powdered charcoal to form zinc vapor. Zinc oxide is heated with the powdered charcoal until zinc vapor is formed due to the reaction of carbon monoxide and zinc oxide. Then the zinc vapor is condensed and collected by dust like particles. Okay, so this is the method of condensation of vapor metal. The next method is atomizing, very important method, atomizing. In this method molten metals are forced through a nozzle into a compressed air or water. In this method molten metal is allowed to force through a nozzle with the stream of compressed air or water, and cooling, after the cooling the metal particles, the metal tiny particles are collected. Okay, so this process is known as atomizing. Okay, so these are the different methods for producing metal powders. Okay, so next step is the blending. Okay, we can say it blending or mixing. Okay, so blending or mixing, the main purpose of this step is uniformity in shape and size. This step is particularly used for producing uniformity of metal powder in shape and size. Okay, so the main purpose of blending or mixing is to produce uniformity of particle size and shape throughout the large amount of powder. Okay, this help in better control of subsequent pressing and sintering operation. There is another thing. In this step, lubricants are added to reduce friction during compacting or compression of metal powder. In this process, lubricants are added to reduce friction during compacting. Okay, so this process is known as this step is known as blending or mixing. Okay, so in powder metallurgy, uh, metals and non-metals both are used. For example, we can take the example of cermet. Okay, which is the which is the combination of ceramic and metals as a powder form. Okay, so here in this powder metallurgy technique, not only metal or alloy powders are used, both metal and non-metals are also used. Okay, so blending or mixing is the basically this step is used to produce uniformity. Okay, so next step is the compacting. Okay, or it is also called briquetting, compacting or briquetting. Okay, in this step, the blended metal powders are compacted or compressed in a steel die of desired shape of the parts to be produced. Okay, so pressure the pressure the pressure required for this compacting is generally 80 megapascal to 1600 megapascal. Both mechanically and hydraulically means are used for creating pressure in this compacting steps. Okay, so here the blended metal powders are converted into a green compact, a green state. It is the not a final product, just before the final product, just step of just before the final product. Okay, so compacting, after blending, compacting is the next process in powder metallurgy process. It is the process of converting loose powder particles into green compact of the desired shape and size. Okay, so generally the pressure required for softer metal is 100 megapascal to 350 megapascal. For harder material, the pressure required for generally 400 megapascal to 700 megapascal. But in general, the pressure required for compacting or compressing of metal powder is 80 megapascal to 1600 megapascal. Okay, so the process is carried out at room temperature in hardened steel dies and punches. Okay, so this is all about compacting. The last step or last process is the sintering. Okay, so before we go to the sintering step, there is an sometimes there is an another step which is called a pre-sintering. Pre-sintering, sometimes pre-sintering is followed. Sometimes pre-sintering is followed because uh, pre-sintering is the process of uh, pre-sintering is the process of heating the compacted metal powder heating the compacted metal powder to remove the lubricants or binders added during blending. Here pre-sintering is basically sometimes it is used to remove the lubricants binders added during blending. Okay, so the temperature of pre-sintering is below the temperature of sintering. Okay, so next is the sintering. Sintering, what is sintering? So sintering, it is the process, or in this step the compacted metal powders are heated below the temperature of the base metal, below the temperature of the base metal to bound together by interparticle bonding. Once again, sintering. In this process, the compacted metal powders are heated below the temperature of base metal to bound the metal powders by interparticle bonding to a final product. Okay, so sintering, what is sintering? Sintering is the process of heating the compacted metal powder below the temperature of base metal in order to form final component by interparticle bonding. Here the metal powders are bound together. Here the metal powders are bound together by interparticle bonding. Okay, when heat is added. Okay, so sintering may be defined as heating of compacted metal powders. As I said, sintering may be defined as the heating of compacted metal powders below the melting point of the base metal with or without the application of external pressure in order to transform to a more dense material by interparticle bonding. Very important step. This is sintering from exam point of view. So sintering is a process of heating the compacted metal powders below the temperature of base metal to form a new component, a new product by interparticle bonding of metal powders. Okay, in this step the mechanical as well as physical properties are increased, like control porosity, then density, mechanical strength, ductility, etc. Okay, generally for steel the temperature of this sintering temperature is 1000 degrees centigrade to 1250 degrees centigrade. Okay, so this is all about the steps involved in powder metallurgy technique, production of metal powders, then blending or mixing, then compacting or briquetting, then sintering. Okay, there are 4 basic steps of powder metallurgy technique. Okay, so next is the advantages. Okay, so what are the advantages? There is no wastage of material throughout the entire manufacturing process. There is no wastage of material through entire manufacturing process, so material is saved. Okay, so next advantages is the part produced have accurate dimension. The parts produced have accurate dimension and surface finish. Okay, there is no need for machining, thus the need for machining operation is eliminated. Okay, so next advantages is the parts with controlled porosity can be attained. Okay, then the skilled workers are not required to operate process or other equipments. Okay, so thus the labor costs are low. Okay, so these are the different advantages of powder metallurgy technique. Okay, so before the advantages, there are some disadvantages. Okay, like powder metallurgy, in powder metallurgy technique it's expensive. Okay, then metal powders are very expensive. In some cases mechanical properties and as well as physical properties are not so good, like casting. Okay, so powder metallurgy techniques is basically limited for small sized parts. Okay, so these are the disadvantages of powder metallurgy technique. Then next is the application of powder metallurgy technique. In case of IC engine, okay, manufacturing of brakes lining, clutch plate, connecting rod, crankshaft, camshaft, and piston rings. Okay, then tungsten filaments of electric valve, radio valves, X-ray tube, oscillator valve, etc. Okay, so clocks and timing devices, typewriter, calculators, and permanent magnets can be manufactured. Okay, so manufactured of toothed components like gear, these are also manufactured by this process. Atomic energy application, material which are very difficult to form, materials which are very difficult for machining. These metals are particularly used this powder metallurgy technique, as already I have said that. So materials which are very difficult for machining, wire drawing dies, press tool, stone hammers, and rock drilling bits can be manufactured. Okay, so next is the manufacturing of grinding wheels, manufacturing of nozzle for rocket and missile. So these are the applications of powder metallurgy technique. Okay, so if you want to know more about this powder metallurgy technique, okay, you can go through this NPTEL link. Okay, lecturer by Dr. Ranjit Bauri, IIT Madras. Okay, so you can you should you should go through this NPTEL link. Okay, so this is all about powder metallurgy technique. Okay, so thank you. Thank you.